This is 8th grade activity 5.3. In this activity, students will investigate the sum of the angle measures of several different polygons. The standards covered in this lesson are 8G5. The page numbers are page 196 through 202 out of the hardcover book, and pages 103 through 106 out of the practice journal. Today we're going to be working with polygons, so you'll need to be open to page 103 out of your practice journal. As I'm working through this, you will also be filling out your practice journal. To find the sum of the angles of a polygon, you can connect each vertex to all of the vertices of a polygon. You can then find the sum of the angles by multiplying the triangles by 180. So first of all, let's go back and review what a polygon is. A polygon is at least a three-sided figure that has straight sides, so no curved sides on the polygon. So all of them that we're going to be working with today are going to be actual polygons. So it has to have straight sides, and it must have a minimum of 3 sides. Okay, so for example, a triangle is an example of a polygon. Okay, a circle is not considered a polygon because it does not have straight edges or straight sides. So it has to have straight sides, and it must have at least 3 sides. Okay, so we're going to go ahead and now understand what they're talking about here. If we were to take the vertice or a vertex of a polygon, so a vertex are your corners where you have 2 sides that meet each other and they make that angle. So kind of the corners of the polygon is another way to think of them. If you were to connect those to each of the other corners or vertices, I'm going to go ahead and do these. It's kind of like a connect the dot, and I'm always going to start with one of them, so I'll start with this one. If I connect to there, it's already a side. If I connect to here, it's cutting through, but it's now making another line. And if I cut there, how many triangles do I end up with? Well, I end up with 1, 2. Not that I had to connect these last 2 spots that I just did, but I'm just showing you that you can see that there are actually 2 triangles on that figure. So if I wanted to find the measures of that polygon, the sum of all of those, the A, B, F, E, C, D angles, they have to equal, well, 180, and each triangle times 2 is going to give me 360 degrees. Okay, so if I have 4 sides, that gives me 2 triangles, which equal 360 degrees. Okay, so let's go ahead and do the next one. Sometimes my eraser doesn't want to work right. Oh my goodness. Okay, so let's look at letter B. Okay, you're doing the same thing that I'm doing on the screen here. So letter B, I have a pentagon that's a 5-sided figure. Okay, so pick one of the vertices. I'll go ahead and pick this one, and you're going to connect to each of the other ones. Okay, already connected. Connected now. Connected. Already connected. So how many triangles, even though my lines aren't perfectly straight, how many triangles did we have? Well, here's 1, 2, 3. So a 5-sided figure gave us 3 triangles. And so now we're going to take our 180 times 3. Okay, when we go ahead and we do 180 times 3, it gives us 540. And you can use your calculators if you need to do that. You don't have to do it longhand. Okay, so let's check letter C here. So letter C, we have a 6-sided figure. So if we do our connecting, okay, already connected. And then we're connected there. So we have 1, 2, 3, 4 triangles. So this time I have a 6-sided figure. And that gave us 4 triangles, which if I take 180 times 4, it's going to give me 720 degrees. Okay, so what I would like you to do is I want you to go ahead and do letters D and E, and then check back on what answers you should have ended up with. So go ahead and pause your video and work your way through D and E. Okay, so on your letter D, your 7 sides, when you did each of from a vertex, you should have ended up with 5 triangles. Okay, and then 5 times 180 should have given you 900 degrees. So when I add all of those angles together that make up that heptagon, they should equal 900 degrees. And then on letter E, our 8-sided figure, you should have ended up from one of your vertex or vertices, you should have ended up with 6 triangles. And then if I take 6 times the 180, I end up with 1080 degrees. Okay? So that's working off of just one method that you can go through and actually find the sum of the measures of a polygon. You don't have to have all of these numbers memorized. You don't have to remember that a 6-sided figure equals 720 degrees. You now have one other method that you can go through and do. And that's where you can connect and find and visually see how many triangles are in there. And we'll be working with another method throughout this lesson also. Okay, so let's go ahead and now do activity 2. So it's taking our information from what we just did and piecing it all together. So here it says, use the table to organize your results from activity 1. So a 3-sided figure, that's a triangle, that's 180 degrees. Okay, and then referencing back to our previous page, the 4-sided figure, which was letter A, was 360 degrees. The 5-sided figure was 540 degrees. So I'm just pulling my information off the previous page. My 6-sided figure was 720 degrees. My 7-sided figure was 900 degrees. And then my 8-sided figure was 1080 degrees. Okay, so we went ahead and filled in our table. Now it says plot the points in the table in the coordinate plane. So we're going to go ahead and plot this information. So we're going to go over to 3 up to 180. Over to 4 up to 360. Over to 5 up to 540. And you can see my pattern now. Over to 6 up to 720. Over to 7 up to 900. And then over to 8 up to 1080. Okay, so there's my line. If I were to continue that line through, it'll help us write our linear equation. Remember, our linear equation is normally y equals our slope x plus where it crosses the y-intercept. Okay, that's back from chapters 2 and 3. Well, instead of using y and x, they want us to use s and n. Okay, so if we were to go through and do that, we would have s equals our slope. What's our slope between these? Okay, if I were to pick 2 of my points, well, the rise was 1 box, but that 1 box was worth 180. The run was just 1, so it'd be 180. Instead of using x, they want us to use an n. So n stands for the number of sides, and the s is just the sum. And then our back half is where it crosses the y line, which we haven't finished that out. So if I continue my pattern, my next dot would be there, then there, then there. So it crosses at 360, and that's a negative 360, so minus 360. Okay, so there's our linear equation. What is the domain of the function? So this was back from chapter 4. So domain, remember, is like our x's. Okay, so our x's, which in this case, instead of x's, they were the n's. So what were our n's? Well, those were the numbers represented here. Now we're not going to include 1 and 2, and that's because 1 and 2, when we have one side or 2 sides, those no longer create a polygon. So here we'll start with 3. So our domain of the function was 3, 4, 5, 6, 7, and 8 of the ones that we were using. Okay, it says use the function to find the sum of the angle measures of a polygon. So our function up here is just our s equation. So we're going to go ahead and substitute in 10 sides, which was our n, our number of sides. We're going to put a 10 where we have n here. So I have our sum equals 180 times 10 minus 360. So if I go ahead and now do this, I get 1,800 minus 360. And when I do that, it gives me 1,440 degrees. So a 10-sided figure is going to have a sum of 1,440 degrees. Okay, so letters F and G are actually not in your book. So these are things that you're going to add in your answers to F and G. It says, look back at page 103. So I'm going to shift back in just a minute to my other slide. What do you notice about the number of sides of a polygon and the triangles that are formed in that polygon? So if we look back, okay, the number of sides, we went from 4, that gave us 2 triangles. Okay, when we had 5 sides, we had 3 triangles. When we had 6 sides, we had 4 triangles. What are we noticing about every situation when we compare the number that we have for sides to the number that we have for triangles? It's always 2 less. So if we know the number of sides, we can find the number of triangles. So I just wrote out the number of sides minus 2. Every single time, minus 2 gave us the number of triangles. If we were to look back at that, if I did 4 minus 2, it gave me 2. 5 minus 2 gave me 3. 6 minus 2 gave me 4. And it works in every single situation. 7 minus 2 gave me 5. So there were 5 triangles. So the number of triangles is always 2 less than the number of the sides that are there. So letter G, once again, you're going to also answer in your book. What is another way that we can find the sum of the angles of a polygon based on our observation? We can subtract 2 from the number of sides and then multiply by 180. Okay. Okay, so if we were to just check that with the one that we just did, doing this equation up here, instead of substituting in for 10, let's try this. If we subtract 2 from 10, that would give us 8. So if we had 8 triangles, would that equal the same number of 1,440? So we're going to take 8 times our 180. Okay, when I punch that in on my calculator, 8 times 180 does give me the 1,440. So it works to also do that. And that's probably an easier method if you can understand that concept, because sometimes you're going to work with polygons that have kind of a unique shape, and it's hard to connect all of the vertices to each other, or there's so many that they're hard to connect. Okay, so let's go ahead and do activity 3. So let me clear this ink. Okay, so activity 3 is actually on your page 105. Okay, so here it says work with a partner, which we're just going to go ahead and do this together. It says a polygon is convex if the line segments connecting any 2 vertices lie entirely inside of the polygon. Okay, so another understanding of that, it's considered convex if all of your angles, all of your vertices are actually pointing out or away from the center. See how all of these, if I just make the corners pointing out or away from the center. So that would be, it has to have all of them pointing out. That would be a convex polygon. Okay, a concave, this is an example of a concave polygon. A concave polygon is when you've got, if you were to connect, for example, if we had used this as our vertice, well, I can connect here and I can connect here, but in order to connect to this vertex here, I have to go outside. Okay, an easier way, when I look at it, it caves in on one side. Also, when you look at the vertices, these point out, but this vertice actually points in towards the inner part of the polygon. So a concave caves in on one side. It says, does the equation you found in the activity 2 apply to concave polygons? Well, if I were to go through and actually do this, this has 1, 2, 3, 4 sides. I could split it here and it still gives me 2 triangles, which would still give me the 360, 180 times 2. So this would be yes. It's probably not as easy to use, okay, when we go through to do that, but it still breaks up into the same number of triangles. It says, how can you define the measure of an angle so that your equation applies to any polygon? Well, I think what they mean from this is for you to understand that if I were to actually try to find the measure of this angle right here, that angle actually is greater than 180 degrees. If I were to measure it from the outer part of that. Okay, so it's actually wrapping around because 180 degrees would be sitting right like this, right? And it goes past that 180 degrees. So sometimes you're gonna have a degree measure that's greater than 180, but really when you look at it and you were to measure this, it would be less than 180 on the outer part of that equation. Okay, so sometimes you will have a degree measure that's greater than 180 degrees for this last answer, okay? So basically that's it for this activity. The key thing to remember is there are 2 ways that you can find the sum of the measure of a polygon. One of them is to split your polygon into triangles by connecting each vertice to a vertex and to see the number of triangles. The other method that we investigated and found out is that you can also count the number of sides and subtract 2, which will tell you how many triangles actually make up that figure, and then multiply that times 180. Good luck with this next lesson.